Okay, so we looked at solving equations that look like this in the previous video. Now we're going to solve equations, I'm going to skip over to the next slide, that look like these, or inequalities, either one. And that now is going to use, and I'm going to go back to the previous slide, that's going to use this property. So e now to the natural log of x equals x. So just like I proved this one, why does that one work? I'm also going to prove this one as well. Okay, because this one's maybe just a little bit harder than the one on the right. Okay, so coming on down here, I've got e to the natural log of x equals x. I want to know, why is this true? Okay, so I notice that I have a base of e on the left raised to a power of natural log of x, and I'm saying that is equal to x. So whatever this is, that would be the answer that I'm looking for. Okay, so now how do I prove this? Well, since I'm dealing with an exponent up here, remember to pull the exponent out in front, we're going to take a natural log on both sides. Okay, that's using this property again. Log base x of a to some power n is the same thing as this. So I'm going to take a natural log on both sides, giving me now natural log of e to the natural log of x equals, since I put a natural log in front, which was right there, I have to put a natural log on the right side. So equals natural log of x. And what does that allow me to do? Well, that allows me to take my exponent, which in this case is natural log of x, and move it out front. So now I have natural log of x, natural log of e, notice how it moved right down in front, equals natural log of x. And before we said that the natural log of e was just a value of 1, so now I have natural log of x times 1 equals natural log of x. Anything times 1 is whatever itself is, so natural log of x equals natural log of x. When is that true? Well, that is always true. And the only way to make that always true is to say that it is equal to the value of x up at the top. So that's the property that we're going to look at. Anytime you get a scenario that looks like this, e to the natural log of x, that will be x. Okay, that's the property that we're going to do. We're going to take that idea and now extend it over to problems that look like this. So 3 natural log of 4x equals 24. Just like what we did in example 4, go back over here. Remember how we got e to the 4x, looking at 4a. We got e to the 4x by itself. We're going to do the same thing with the natural log. I want to get natural log of 4x by itself. So in order to do that, I'm going to divide by 3, leaving me with natural log of 4x equals 24 divided by 3. That gets me 8. And this is where your property comes into play. I'm going to use e to the natural log of x equals the value of x. So what I'm going to do is I'm going to take a base of e, and I'm going to shove everything else up into the exponent. I can do that. I can take and raise everything. I now have e. I'm making this in the exponent. If I make natural log of 4x into the exponent, then I have to use the same base and raise 8 into the exponent. It's kind of going backwards from what we said before. You notice when we were in this situation, we normally drop the base and we set, whatever the exponents are equal to each other and then solve. Well, now we're just kind of going backwards. I want to make everything the same base and shove everything up into the exponent. Okay, it's not natural for us to do it this way, but this is going to be how this works and to solve these problems. So now I'm going to look at the left side over here. I have e to the natural log of 4x. Notice that looks very similar to this over here. e to the natural log of x is just x. So whatever this is what this becomes over here. So since x really is the same thing as 4x, we now have 4x, this is our next step, 4x equal to e to the 8th. The e and the natural log basically disappear, they go away, and I'm left with 4x on the left. Okay, and then you can keep solving. To get x by itself, you divide by 4. X equals e to the 8 over 4. You can plug that into your calculator. Notice it wants 10,000th place. So when I plug that in, I'm going to get 745, big number, 0.2395. Right, and that will be my value that we're looking for out of this. We'll also do letter B. Okay, this one just uses an inequality, but it's pretty similar. You just need to make sure that you're not dividing by negatives. This one does add a step to it. Notice this time I have an exponent up here. I'm going to use my exponent rule first, and since I have a natural log, I can take this exponent and move it out front right away. So now I have 4 natural log of x minus 8 is less than 4. And I want to get the natural log by itself. So in order to get the natural log by itself, I have to divide both sides by 4. Divide by 4, that leaves me now with natural log of x minus 8 is less than 1. 4 divided by 4 is 1. And this is where your property comes into play again. We're going to raise everything up into the exponent, and we're going to use e as our base. Is less than, this is technically e to the first. Okay, and why that helps us out? Well, now our e and our natural log, they're going to cancel, leaving me with just x minus 8 being less than e to the first. And then to get x by itself, we're going to add 8 over. X is less than e to the first plus 8. You can plug that into your calculator. We need to say that x is less than, looking here, 10.7183 when you plug that into your calculator.